Okay, so we're looking for the equation of g of x in simplest form, which results when f of x is vertically dilated, that should say, not dilated. So if you'd like to change that. So it's vertically dilated by a factor of 4. So the vertical dilation tells us that g of x is going to be 4 times f of x. The vertical dilation factor is outside of the function. So that's just going to be 4 times x squared minus 2x plus 3 equals 4x squared minus 8x plus 12. So fairly straightforward. Tips for new players, make sure you're putting the scale factor in the right place. If it's vertically dilated, it goes outside of the function. If it's horizontally dilated, it multiplies every x within the function. So our next example is a horizontal dilation, and it's asking us to find h of x in simplest form, which results when f of x is horizontally dilated by a factor of 1/5. So if the factor equals 1/5, then k is going to equal 5. Notice that we have to make that adjustment before we make the substitution. So h of x is actually going to be f of 5x. It's horizontally dilated, which means it goes inside the bracket, and because it's horizontally dilated, the factor and k are reciprocals of each other. So from there we write out f of x using 5x instead of x. So it's 2 times 5x cubed minus 3 times 5x plus 5. Remembering our index laws, the cubed applies to both the 5 and the x, minus 15x plus 5. 5 cubed is 125. 2 times 125 is 250. X cubed minus 15x plus 5. Now, you kind of look at those two functions and go, have I got that right? Because one is 2x cubed and the other is 250x cubed, which initially seems like it might not be right. So let's have a look at the graph. I've graphed them down here using f of x. And you can see that indeed the function has been compressed horizontally, and you can eyeball it by looking at the maximum and minimum points. So here's our maximum, one minimum, the other minimum. You can eyeball it, you can measure it. Probably the easiest way to actually check though is to use the axis intercepts. So the first intercept is negative 0.344 and the second intercept is negative 1.79. If this is in fact a scale as a dilation of a factor of 1/5, then negative 0.344 should be 1/5 of negative 1.79. And if you do negative 1.719 divided by 5, you will find in fact that it is negative 0.344. And so you can confirm that even though the numbers seem unlikely, that it is in fact the correct dilation. All right, that's enough to get you going on exercise 3F.2.